Hi everyone, please take your seats. We are starting. This is too loud. So, there's no quiz today. Instead, we'll do something that's kind of quiz-like to show you what things would be like if we had a quiz, which, well, I thought it would be like not completely reasonable to do today. So, several things are on the agenda. So, we'll review again communicating information to and from functions. And then, kind of subject to time constraints, we'll start loops. So for loops and then while loops. And possibly, if we're feeling ambitious, modular. And the reason we're doing this is really because in order to do anything interesting with while loops, or indeed for loops, you at the start need like some kind of math. So we'll do modulo. So I want to, again, kind of, because I think at this point in the semester, some people are starting to think, oh, I'm really behind. So what to do in this kind of case? So first of all, you have the first two labs, and just work on them. If you need extra help, that will be available in terms of being kind of both my office hours and contacting the TAs, probably a little bit online, a little bit in person. We'll see how that goes. So that will be announced within the next couple days. But also just by yourself, you can go and just try to redo the lab. If you got the solution, maybe from a TA, maybe the partner helped you, that's completely okay, but you want to make sure that you can do those from scratch. If you can do lab 2 from scratch, you're not behind. So if you feel like you can't, well, you want to get to the point where you are. How to do it? Well, look at the solution. So I'll post the solution on around Sunday, just because some people are sick, stuff like that, so they can get an extension. But the solution would be posted on Sunday. You can look at it and kind of look, convince yourself that, okay, now that I know what the solution is like, I can do it from scratch. You want to guard against just memorizing it, because that's not useful. You want to say, okay, I understood the solution enough that I now have in my mind a path to how to solve it, rather than literally just I remember the solution because I have photographic memory, and then just solve it. One way to do it is, like read the solution, maybe go do a little bit of calculus homework or something to relax, and then come back and do the programming assignment again, just to make sure that your mind is clear. And it's not just that you have like a picture in your mind of what the literal text of the solution is like. So, okay. Alright, so I'm starting the actual content, so I'm asking that everyone turns the volume down. Alright, thank you. So I know it kind of this room can feel like you're at the baseball game or something, but it's not. I'm terrible at baseball. So that's why I got to be quiet. Okay, all right. So I want to just look at the examples, and, well, like, honestly, you can just run them as well, but I want you to think about them as, okay, pretend that you don't know what's going to happen and try to predict what's going to happen. So I'll copy paste the first example. So will this change the value of grade? So will it print 95 or will it print 90? Okay, who thinks it's going to be 95? Who thinks it's going to be 90? Okay, there's a lot of people without opinions. So if you don't have an opinion, I want you to actually now discuss it with whoever's at your table to come to a conclusion about what this is going to be. So give it like a minute. Who thinks it's 95? Who thinks it's 90? Okay, yes, you're right, it is. So why is it 90? Well, because here we said global grade, right? And if we say global grade, then that means that when we're trying to change the value of grade over here, we're adjusting this grade. So that means that when we print it on line 15, yes, it's going to be the new one. So one interesting thing to note here is that if you comment this out, what's going to happen is it's going to say error. So why is it going to say error? Well, it's because of this instruction over here. So here you're saying grade is equal to grade minus 5. But inside the function, you have not said global grade, and you also have not defined a local variable grade. So the only way to interpret it concentrating on the right-hand side is, well, grade must be global. Why? Well, because it's not local, there is no local variable named grade. On the other hand, here you didn't say global grade, so you're saying grade equals. If you said grade equals anything that doesn't involve grade, then grade is local. So that's an ambiguity that Python chooses not to resolve, so this kind of thing would result in an error. This is similar to another kind of way to produce an error that we already saw, which is this. So that is also an error for a similar reason. Right? So if grade is a parameter must be local, like we said last time. There's no exceptions. But then you say global grade. So that would also produce just a syntax error, meaning Python says there's no way that this can be right. This is just not according to the rules of Python. So there's not many situations like that. It's more an exception than a rule. So for the first months, those are the only situations where you're producing something that would result in a syntax error as a result of this global local construct, right? So one is you say that something that's a parameter, oh, actually it's also global. That's a conflict. And then here, this is the new one that I'm just introducing, is you're saying grade is equal to grade minus 5. So here in the same statement, you are kind of implying that grade must be global because you're saying let's use the value of grade, and you've never defined grade inside the function. So that means that the only way that grade could exist is if it's global. And then you're saying, oh, put it in grade, but grade equals ordinarily means grade is local unless you say global grade, which here we didn't say. So it sounds complicated, but really those are the two situations. That's it. Make sense? So let's see what Discord is saying. Discord seems excited. Okay, I think, oh, it's like, okay. No idea what anyone is saying. Okay, all right. So technical Q&A is here. I'm not looking at the spam channel. Okay, all right. So that's like that. So let's go to the next example. So what's going on here? So here we have two print statements, right? So one print statement is over here, and one print statement is over here. By the way, you might be wondering, can I have two main blocks? Yes, absolutely you can. It's just an if statement, right? So it'll just that it'll run this, and then it'll run this. A little bit unusual, but not a problem. So we're looking currently at this chunk of the code. So without looking and without running it, I want you to try to discuss what the output is going to be. So let's take two minutes. Yeah. Only what I'm selecting, yeah. So it prints two things. So we're going to do a vote. After that, we're going to vote on whether we'd have an exam or not. I know, it's a democracy. So what are the possibilities here? I guess 90 and 95 would be one possibility, and then another possibility would be they're both 95, and another possibility would be they're both 90, and another possibility would be 95, 90. All right. Which tables say A? Which tables say B? C? D? All right. A wins. So, so let's see. Yeah, give yourself a hand. Yeah. So let's see what's going on here. So here we're saying grade is equal to 95, and we're saying adjust grade. So what happens is this grade gets sent to this grade. So it's a little bit unfortunate, but those kind of situations happen all the time where there is a global variable named grade and there is a local variable named grade. They're separate. Initially, when this grade gets sent to this grade, they're equal, but they're conceptually separate. It happens very often that they have the same name. I'm not trying to confuse you. It's just that if they represent the same value, at least initially, it would stand to reason that they also would have the same name because it's the same value. So it's a little bit unfortunate, but it happens all the time, right? So we can try to keep track of those things by just saying we'll have a more elaborate system later on, but for now this will do. So the local grade does not exist initially, and then the global grade is initially 95. Right? So once you've said grade is equal to 95, the global grade is equal to 95. We're then saying adjust grade to grade, and then what happens, so we can specify even local in adjust grade to. So then what happens is this value gets sent to this value. So that also becomes 95. Make sense? So then we say grade equals grade minus 5. Inside here, we never said anything is global. So that must mean that we're assigning to the local variable grade. And there is a local variable grade, so it's got to be the local grade minus 5. So that means that this is 90, and this becomes 90. We now say new grade inside the function is 90. So that what gets printed. Gets printed. Once this function finishes running, that's it. This, in a way, is just gone. The only value that exists is 95, so that's the only thing that can get printed at this point. Make sense? So, okay. So that's this example. Let's do this one. So here we have, okay, adjust grade, and again, we're printing two things, and again, we have the different options. So if I give you 2 minutes for everything, then we're going to run out of time. Let's say 90 seconds. Let's think about this one. Just discuss. Who says A? Who says B? Who says C? Okay, some people. Who says D? Okay, some people as well. So a spread of opinions. Trick question. It is still A. Nothing changed, right? So the only thing that's different between the previous example and the current example is the G. Here used to be grade. It doesn't matter, as a general rule, what you name a local variable. So the example that we used before was, like you say, like f of x is x squared, just in math. And you say g of y is equal to y squared. Well, it's exactly the same. It doesn't matter. As long as you're consistent, it's the same. So what's happening under the hood in Python? Again, like exactly the same thing, it's just that the global grade gets sent to the local variable that's now named G, as opposed to being sent to a local variable that's named grade. It's the same. All right. So, okay, here it's like a simple thing, so let's look at this one. So what happens here? So here we're saying global grade, and then we're saying grade is equal to G minus 5. And then we're saying adjust grade 4 of grade. So what happens? This is 95. The 95 gets sent to G. And then we're saying change the global grade to be G minus 5. So the global grade, this guy, gets changed to 90. So that means that this guy prints 90. Okay. How do you see it? Well, I mean, you have to always look line by line, but just by eye, well, you see that there is a global grade declaration, and it says set the global grade to something new. At that point, you just need to figure out what the new thing that the global grade would be set to. And here, grade is outside of any function. That means that it's global. What about this one? So here we're doing something different. So before we were printing, and then we're setting the value of a global variable. Here we're returning, right? So what's happening? We're saying grade is equal to 95. Then we're saying get adjusted grade, and get adjusted grade returns something. So that means that the value of this expression is going to be 90. However, it's just that the value of this expression is 90. We don't do anything with this expression. We don't say print this. We just say get adjusted grade, don't use it. And then we say new grade outside the function. Well, that's still 95. That's because this expression by itself never did anything. This, by the way, is linked from the course website. Does that make sense? Questions about this? Yeah. Well, it would print 90, so there would be two things printed as opposed to just the one. So if you said print grade minus 5, yeah, like this line, if it were print grade minus 5, that would print 90, and then you would get to this line, and that would print 95. All right? So how do you fix it? Well, here's how. So you say grade equals to get adjusted grade. So now the value of this is 90. And then you say take 90 and put it into grade. And then you print grade. Well, that will print 90. Right? So questions about the distinction between this guy and this guy? All right, let's see what Discord is saying. Okay, so there's questions here. So, yeah, okay, so this was a question. So is the parameter g assigned to grade or directly to 95? That's a good question. This is a question that I'm not going to answer. Well, I mean, I'm happy to answer. The answer is it's the other way. Grade is assigned to g, not directly to 95. However, currently that doesn't matter. So you can think of it as 95 is getting assigned directly to G. You won't lose out from anything. However, technically, the answer is grade gets assigned to G. So G is the thing that's being assigned to. Grade is what's being assigned. And really, it's grade that gets assigned to G. It doesn't matter because grade is bound to 95. If you try to say elsewhere grade is equal to 94, it's going to be that the old grade is still bound to G, which was 95. The new grade is separate. For now, don't think about it. Just think about it. 95 goes directly to G. That's fine. So that's incorrect. It does not copy the value. So we'll talk about it in. It is a pointer. Well, it is a reference, which is not quite a pointer, but something like that. Anyway, that's advanced stuff. That should go into a hash nerd phase if you like to discuss that. So that's like that. So we've already seen the examples here. So this creates an error. Why does it create an error? Well, like we said, if you say grade equals grade minus 5, then the left-hand side without global grade implies that grade is a local variable. However, the fact that grade was not defined anywhere up above implies that the grade on the right-hand side is a global variable. Python just, well, in this case, there's like not a good way to resolve it. I suppose we could say, well, we'll get the global grade for the right-hand side, and then the left-hand side is going to be local. That's not great either. So Python just says that's a syntax error. Okay. So, so this is something we discussed last time as well. You can pass data this way, where you just say, okay, like -510, and then the return value of -5 is a global variable, so every time you call the function -5, so call means plug in arguments and get the value, or get the function to do whatever job it's supposed to do. You can do it, and then the result would be stored in retval -5. You can see, I hope, how in lab 2 it made sense to do things that way sometimes, because there were so many variables that you needed to set. Can't see who's talking, but someone's talking, and if I see you, I'll say the name of your table, if that deters you. I guess the person who's talking is not listening to my threats. Okay, quiet down, everyone, please. Oh, you. VO5. Okay. All right. Delta 5. Thank you. Okay. So the right way to do things is almost always to pass information this way. So the way we pass information into the function is by making it an argument. So in this case, for example, -5 to 15 gets sent to x. The right way to get information out of the function is to return it. So here, for example, we send in 15, and then we get this, whose value is 10, and then we print it. That's 95% of the time, that's the right thing to do. That's what you're supposed to do, unless specifically told to do something else for some reason. In a couple of months, hopefully you have enough experience that you try to make your own judgments as well. If your judgment happens to be that you need to use a global variable, your judgment is probably wrong. But, not always. Okay, all right. Questions about any of this? All right, let's look at what Discord is saying. So please, no memes on Q&A, please. Okay. Skull emojis only in good measure, not too many. Okay. So the next thing I want to talk about is loops. So far, the programs that we've been writing So far the problems that we've been writing, to be honest, they weren't doing much, because it was always just, okay, if I give you this input, just do something that the calculator could do and get it back. So really the power of computing is in being able to repeatedly do some kind of operation in order to compute something that a human just could not compute in reasonable time. Okay, and so this is sometimes called repeated computation. Students usually just say loops. And the simplest thing that you can do in Python is something like this. So I'll explain everything in a second. Okay, so something like this. So what's happening here? Well, you can read it as just, this is a way to repeat something 5 times. And a lot of the time, if you just want to repeat something n number of times, this is how you would do it. You would just say for I in range 5, and then you would say inside here, whatever you want to repeat. And here you see the same instruction. The print was executed 5 times. All right. And that's a useful way to think about it. Sometimes people overcomplicate things. But really what's happening as well is the I gets set to 0 and then 1, then 2, then 3, then 4. So really for I in range 5 means go from 0 and up to whatever is 5, but not getting up to 5. And execute the block. So I can say, let's change it up a little bit. So something like this. So what's happening here? So first I was set to 0 and this was executed. How does that work? Well, we print this, and then we print the I, which is first it's time number 0, and then it's time number 1, and then it's time number 2, time number 3, time number 4. And this is executed every time. So you could try to fix it. So like if you think that there is no time number 0, you can say like print I plus 1. And then I is still 0, 1, 2, 3, up to 5, not including 5. But when I is 0, you're printing 1. When I is 1, you're printing 2, and so on. Yes? So it's not really about, the answer is no. The syntax is actually quite complicated. So we'll do more details on that later on. For now, we're just using this. So just think about it as set I to 0 to 1 to 2 and so on. Why I'm not explaining the syntax? Well, like in order to fully explain it, you would say like range is actually a function that returns an iterator. It's a whole thing that's usually done in like second semester. We'll do a little bit more details, but there is a simplification going on, which is this just means for now I is 0, then 1, then 2, then 3. Okay? So, okay. So that's like that. So, in order to do some kind of computation, rather than just so let's do something. Okay, let's do 500 just for the fun of it. But so that's the power of computing, right? So like it would take a really long time to type up, but now you can just write a Python script that'll print whatever you want. So I want to do something that's kind of a little bit interesting. And in order to do that, I need to introduce modular arithmetic. So you actually already heard about it probably in elementary school, but you might have forgotten. So modulo, also known as remainder, is like this. So if A is not divisible by B, we can say, in fact, even if it's divisible, we can also say it. We can say something like A divided by B, so we'll write it as 2 divide sign because that's how we write it in Python, is equal to just floor A divide B, right? So what we mean by that is just round down, right? So like 7 divided, so whatever, like 15 divided by 2, you can write it as like 7, and then there is a remainder, right? And then you can say, okay, so ordinarily, what does it mean that you divide something? Well, if you multiply it back, that's going to be equal to A, right? That's just how division and multiplication work. And then with the remainder, you can say B times, so this is for positive. So with a remainder, you would just say b times a divided by b. So that's not going to be always quite the same as a, because you might have rounded down, right? But you can add the remainder, so this would be the remainder. Usually I write it with spaces, and that would be equal to a. So the remainder is the thing that you would add so that b times a divided by b is back to being a again when multiplied by b. Yeah.
So the double slash.
So I'll do that in a second. So yes, so the double forward slash is integer division. Yes. So as opposed to 15 divided by 2, which would be float division. Right? And then the remainder here is going to be 1. Right? So another way of thinking about it, if you subtract 1 from 15, then 14 divided by 2 is going to be exactly 7. Make sense? Yeah. What if you did b percentage a? So if you do a smaller, number mod a larger number, it's just going to be the smaller number, and that would be because 5 divided by 12 is just 0, right? So in order to make it up back to 5, you need to just add the 5 back. So that's always just going to be 5 for positive numbers. So there is a slight. So here I said for positive a and b. So there is a slight kind of like difficulty, which I don't think is worth thinking about too much. But if you do something like minus 15 divided by 2, then you'll get minus 8. And then if you do 15 divided by minus 2, in this case, you'll also get minus 8, but it's not worth, so it's not rounding down, it really depends. In this case, it seems to be. And it also depends on the version. It's not really worth kind of thinking about, okay, why is it minus 9 and like not whatever you might think, or like maybe you'd think minus 8. The way to think about it is the only thing that's guaranteed is if you compute this kind of thing, then that's always going to be equal to 8. So the modulo is going to match up. So here we have minus 17 divided by 2 is minus 9, and then you do minus 17. Who is talking? What's F in NATO alphabet? I forget. F09. Hello. All right. So if you do something like this, it's always going to work out. So in particular, you do something like this. The remainder is 1. So indeed, you do minus 17 divided by 2, and you back multiply it by 2, and then you add minus 17 mod 2, and you get minus 17. Yeah. Well, so no, that's what I'm saying is that's not the case. So what is the case is that with the modulo, it's going to work out. You shouldn't be thinking like to be honest, like if you're doing it with negative numbers, there is a result that you expect. So just explicitly code it if there is a result that you have in mind. If you don't have a result in mind, well, that makes no sense. Like you got to know what you actually want there. Right? So it's not worth relying on those rules for negative numbers. It's just like figure out what it is that you want and then code it explicitly. Yes?
operation only
well, not always, right? So it might give you a negative number. It can, right? So you can. So if the inputs are negative, it'll do something. You just shouldn't be relying on what it's going to do. It depends on the language, depends on whatever. Right. Right. Yeah. So it might like the only thing that's guaranteed is that this is going to be true. Okay. Yeah. Yeah, you can, but it's like honestly, it's not worth doing. Like sometimes, like you want to know like how many multiples of pi there are in a number, something like that. But honestly, I wouldn't rely on this because again, this is language dependent and like language version dependent. So I don't recommend trying that. Or trying it to try it, you can. I don't recommend relying on it in kind of actual code. So okay, all right. So now that we have that, I can say, how do I know if A is divisible by B? Well, if A is divisible by B, what it means is that the remainder, if I try to divide A by B, the remainder would be 0. Right? Great. So that means that I can just say, okay, so how do I check if n is a prime number? Well, the kind of most straightforward way to do it is to say, well, check if n is divisible by 2, and then check if it's divisible by 3, and then check if it's divisible by 4. So that's a little bit superfluous, but can't hurt. And so on. And then, again, a little bit superfluous, but you can check if n is divisible by n minus 1. And then, if it's not divisible by any of them, then you know that it's prime. If it was divisible by one of them, then you would say that it's not prime. So let's write this function. We'll call it is prime, and we want to return true if n is prime, false otherwise. So let's first write the same kind of for loop that we wrote already, just saying that this is what we want to do. So here I'll say for I in range n, and I'll say is n divisible by, and I'll say I, and I'll say question mark. And then here I'll use this. So this is what it doesn't compute anything yet, it just prints it, right? So several issues here. So I don't want to check if it's divisible by 0, really. I don't want to check if it's divisible by 1. It definitely is. I sometimes want to check if it's divisible by 2, except if it's equal to 2, then I don't want to do it. So how can I fix it? Well, one way to fix it is to say, okay, I don't want I want I plus 2. So then the 0 would become 2, the 1 would become 3, and so on. But then I'm overshooting. The 11 is the last thing that I want to check. So I'll just say, let's go up to n minus 2. Right? Because I'm overshooting by 2. I'm checking 13 and I'm checking 12 because I added the 2 to I. So I'll run it like this. And I'm out of time. We'll continue next time on Monday. And I'll see you. Yeah, have a good weekend. Bye.
Yeah, so
that's what I'm saying. It's not about rounding. It's not about rounding up or down. It's like a complicated system that separate out different segments of the code and helps you with that. So again, it's a bit displayed there. Yeah.
I just wanted to ask if there is like some online course or YouTube videos which I can watch this evening to cover up all the material that is missing.
Of course, it's on YouTube. So on the
Is there a specific one which you would...
Wait, this literally this course is literally on YouTube, right? So if you go to the course website, there is a YouTube live stream. Yeah, so the answer to your question is yes, like literally it's on YouTube. Yeah. So the problem is when you're saying grade equals... Hello, sorry. So I'll answer questions outside. Sorry about this.
Also pick up my stuff?
Yeah. You're your own person. You do what you like. Which course is it?
Yes, please.
Oh, okay. Oh, it's just that. Yeah, it's just that I haven't seen you before, so I was wondering if it's like a new. Yeah, so it's just that.